Welcome, everyone. Today, we're going to walk through what it actually takes to build an AI project responsibly using three real scenarios to show three distinct phases: strategizing whether the product is even feasible, mapping a roadmap from prototype to deployment, and mitigating the ethical, legal, and societal risks before scaling. Hi, my name is Nan Ross, and I am an Agile Product Delivery instructor and an AI consultant. I help professionals learn how work moves from idea to execution and delivery. So each phase in this checkpoint is not a formality. Skip one, and then the project would get expensive and even more dangerous later. So every AI project, regardless of industry, tends to move through these three phases. Well, they might have a different name for it, but first is strategize. You want to investigate whether the idea is even feasible. Is the data ready? Is it technically possible? Does it make business sense? Second, roadmap. Once it's feasible, move from a small prototype to a pilot to a full deployment in stages, so failures are caught early and cheaply. Third, mitigate. Before scaling to real people, review the ethical, legal, and societal risks and put safeguards in place. Now, we'll look at one real example for each phase. So let's start with phase one, which is strategize. Before anyone commits budget or engineering time, a feasibility investigation answers a simple question: should we even build this? Our example is a proposed AI chatbot for customer support. The investigation covered data readiness, technical feasibility, business viability, and risk, all before a single line of production code was written. On the data side, the team needs to identify what data sources were even available, confirm that the chatbot's knowledge content was approved and up to date, and assess whether any protected health information or other sensitive data was involved. Now, on the technical side, they mapped out what systems that the chatbot needs to integrate with, such as a CRM, a scheduling, a knowledge base, and they clarify exactly who would use it and for what. Notice this all happened before any model gets built. So basically, you are de-risking the plumbing first. Feasibility isn't just a technical question, it's a business one too. The team had to define what success actually looks like and which KPI would prove it. And then they had to surface unknown that would stall approval together. So in parallel, they would characterize the risk landscape, such as the privacy and the compliance exposure, bias, patient and user safety, misinformation, and how the system will handle escalation and real world adoption. Naming these risks early is what makes this next slide recommendation credible. Here's the actual board that we ran this investigation on. So let's walk through this slide. First, we have data readiness. It's our list that covers identifying available sources, confirming the chat box knowledge content is approved and current, and checking for PHI or sensitive data. Next, we have technical feasibility map requires system integration and whether the bot needs to touch the CRM, scheduling, or even knowledge-based system. Business viability requires success metrics and KPI. Risk and unknown captures privacy, compliance, and bias concern, plus data safety and misinformation risk. Assumptions actually lodge what we taken on faith about data, stakeholder support, and integration feasibility. And next step recommendation is where the board renders its verdict: proceed, pause, or revise. So here's the outcome. After logging every assumption about data readiness, stakeholder alignment, and integration feasibility, the recommendation wasn't build it or kill it. It was go to discovery. That's the point of the feasibility phase. It's the gate that decides whether you're ready to invest further, not a rubber stamp. A lot of teams skip straight to build in, and this is what it looks like to do the step before that properly. Phase two is the roadmap. Now, once a project clears feasibility, the next question is how you actually get from the idea to something running in production without breaking things. Our example here is an AI model for reading medical images. It's a much higher stake environment, which makes the stage rollout even more important. So let's walk through prototype, pilot, and deployment. The first stage is proving that the model can work at all in a low stakes setting. The data science team trains an open, publicly available chest X-ray dataset, establish baseline sensitivity and specificity threshold so they'll know what good looks like, and validate against a small set of anonymized test images. Nothing here touches a real patient or a real hospital system yet. It's just proof of concept. Once the prototype clears its bar, the pilot brings into a new workflow carefully. The team integrates with an imaging system in one hospital department, but ran it in a silent mode, meaning that the AI made prediction that radiologists never saw, so nobody's decisions was influenced yet. They compared the AI prediction against what radiologists actually concluded, and then ran a bias audit across patient subgroups like age, gender, and race. Now, this is the stage where you'll find out if the model behaves the way that you hope, with real world data, before anyone relies on it. Only after the pilot holds up does deployment begin, and even then it's staged. The system scaled to all hospital sites, but radiologists move into an augmented workflow where they can see the AI suggestion rather than being replaced by them. The team add real-time monitoring, dashboards to catch sensitivity, specificity, or draft problems as they happen, and then complete the HIPAA, the HIPAA, and the FDA documentation while training staffs on when and how to escalate. Deployment is not the finish line, it's an ongoing monitor state. Now, this is a roadmap for a medical imaging project. Let's walk through these live. First, we have prototype. Now, the prototype has data science training on an open chest X-ray dataset, establishing baseline sensitivity and specificity threshold, and validating against a small anonymized team set. The pilot is where it gets real, integrated with the PACS in one hospital department, running in silent mode so radiologists never see predictions yet, comparing the AI output against radiologist interpretation, and a ethics and governance card running a bias audit against age, gender, and race. Deployment scales integration of all the sites, enables the augmented workflow, and monitoring dashboards for drift, and to close out HIPAA and FDA documentation, plus staff training. Notice that ownership shifts across the board. Data science, they lead the prototype. Engineering and ethics actually shares the pilot. And then engineering and compliance share the deployment. Phase three is mitigate. Even a technically sound, feasible, well-piloted AI system can still cause real harm if you don't examine its ethical, legal, and societal implication. We're often called as LC review. Our example is a hiring assistant designed to automatically screen and rank job applicants. On paper, it promised real efficiency gain. The question this review asks is, what is risk in exchange. Ethically, three things stands out. The model is trained on historical hiring data, which means that it can repeat or even amplify whatever discrimination exists in the past. Its rankings are hard to explain, so candidates can't understand why they were rejected, and recruiters can't fully explain the system reason either. And it shifts real decisions from people to an automated process, which raises the questions of who's accountable when it gets something wrong. Legally, that translates into disparate impact liability. Even when the system looked neutral on its face, exposure to emerging regulation like the New York City Local Law 144 plus privacy law and a weak audit trail that would be difficult to defend in a complaint or lawsuit. So zoom out, and the societal risk is bigger than anyone's hire. Automated screen spreads discrimination across many applicants and job openings at once. Candidates, they start to distrust a process that they can't see inside or challenge. And a narrow, data-defined idea of fit can quietly shrink workforce diversity instead of improving it. The response isn't to abandon the tools, it's three safeguards. Put a human in the loop on every AI-driven rejection, run independent bias audit on an ongoing basis rather than once before launch, and govern the data itself by excluding sensitive attributes and anonymizing candidates' records. So the final call isn't a full launch. It is a phase rollout gated by evidence. So start with a third-party fairness baseline audit so you can have an honest starting point. Run a limited pilot in just one job family or region with a human reviewing every single rejection. Bring in an independent reviewer to look at the pilot's outcome, the audit's results, and the recruiter's feedback together. Only then make a go or no-go call on expanding further. Each stage has to earn the next one. So to bring it together, three different projects, three different phases, one underlying discipline. Strategize means that you don't start building until data, technical, and business viability are actually viable. Roadmap means that you move from prototype to pilot to deployment in controlled, gated stages rather than jumping straight to scale. And mitigate means that you review ethical, legal, and societal risks before you scale, not after something goes wrong. Any AI project in any domain benefits from running through all three. Thank you, and I'll see you in the next video.